Hi, Assalamualaikum. I bid to everyone. First of all, let me introduce myself. My name is Ainatul-Fatima binti Mat Muhazi, and I am from Mitrans. Here am I to make a short presentation on my article entitled Methodology Development of a Road Network Assessment Model for the Campus Environment. My presentation is divided into 5 main parts, and I'll start with introduction. First and foremost, what is IRAP? Well, IRAP stands for International Route Assessment Program. It is a global organization that acts as a tool or instrument or an approach dedicated to improve road safety and reduce the number of road traffic injuries and fatalities around the world. With IRAP, we can assess and rate the safety of roads from 1 star to 5 stars and develop recommendations for safety improvements. For your information, IRAP's plan is aligned to the Global Plan for the Decade of Action launched in October 2021, of which achieving 3-star or better journeys is one of 5 key areas of actions. Note that 1 star is bad, 3-star is okay, and 5-star are really good. With IRAP, every road in every country should be rated at least 3 stars to achieve global standards. Did you know that IRAP implementation in Malaysia is mainly focused on highways and schools? For highways, IRAP is conducted on all road user groups, while in schools, it targets vulnerable road users. An ongoing research st- uh, an ongoing research study was undertaken at UiTM main campus to evaluate the safety risk present on the campus environment using the IRAP. However, the study requires some adjustments to suit the local needs. Even though it is similar to IRAP at school, however, campus settings cater to more space and networks within the campus. Thus, this study aims to develop a methodology for implementing the IRAP at campus with the objective of identifying the crash risk in the campus environment, establishing the IRAP star rating for the main campus, and third one, to recommend high-impact improvement plans that suit the campus environment. Turn to literature review. This figure shows the IRAP methodology involving the IRAP star rating and safer road investment plan. This IRAP methodology is also similar to the previous one. Meanwhile, this is the methodology implemented at school in Malaysia. Similarly, it involves data collection, surveying, and analysis process. To simplify, the IRAP approach has 4 major processes. A road survey is the first step, and then data coding follows. After that, star rating score, then star rating, and finally, safer road investment plan. This study involved reviewing both local and international publications and information from diverse sources. Let's now turn to the most significant part. The proposed IRAP methodology for the campus environment involved data collection, road attribute coding, data analysis, which involves star rating analysis, and benefit cost ratio analysis to come out with crash risk identification, star ratings generation, and finally recommendations plan. For IRAP at campus, spot speed study and road survey are necessary, where the data is later used in the road attribute coding phase. As can be seen, these are the illustration of the road attribute coding. This is the process of video-based inspection, and the second figure here is the coding, shows the coding is done in Microsoft Excel. From star rating analysis, objective number 1 and objective number 2 can be achieved. Meanwhile, recommendation plans are concluded after computing the benefit cost ratio. For star rating analysis, there are 3 scenarios the study wants to observe. Firstly, the study wants to observe the star rating pattern if road users comply with the speed limit. The second scenario is the star rating pattern when data is coded based on operating speed. That's why the study needs to collect data from the spot speed study. From the star rating results, based on observed operating speed, the coding data is reanalyzed to see the pattern of the modified star rating. In order to conduct cost-effective countermeasures, PCR analysis was measured. There are 6 data points needed to calculate PCR. First, baseline injury data where average of at least 3 years data is needed. Secondly, value of human life and serious injuries, which computed using a formula. Thirdly, discount rate, where in the IRAP model, the discount rate was set at 12% by default in Malaysia. The fourth one is cost of countermeasure, where obtained from the respective organization. And then effective of countermeasures, which obtained from the Road Safety Toolkit website. And finally, service life, where each countermeasures service life was standardized to 20 years in the IRAP at UITM campus study. For IRAP at UITM campus, these are the significant elements that are modified to improve the star rating. Firstly, it is roadside, and the modified item was roadside severity sight distance. Secondly, the mid-block element and the modified items were road condition, skid resistance, delineations, and street lighting. Next is improving intersection quality. Fourth, improving VRU facilities, including pedestrian crossing facilities, pedestrian crossing quality, and sidewalk. Lastly, improving speed management. We have almost come to an end. The contribution of this paper is the methodology for producing a road infrastructure risk assessment model with parameter adjustments to suit campus environment, subsequently providing a sufficient budget for road maintenance based on ROI. Finally, for continuation research, it is recommended to complement IRAP with road safety audits in the road traffic engineering field, and to develop a model to assess pedestrian and motorcycle risk based on traffic conflict count, since the tendency for road crashes on campus is low. Well, that's complete my presentations. Thank you for listening.